Looking at problem 31, it has a 750-piece jigsaw puzzle. We're trying to make it a little more puzzling and a little more challenging by including 5 additional pieces. What it's asking for down in our problem here is the probability that if we're drawing out one piece at random, that it would be one of the extra pieces. Anytime you have simple probability this way, what you have is what you're looking for, or the desired outcome, over the possible. So our desired outcome is our extra pieces, the 5 extra pieces. So that's going to be 5 over the possible outcomes. Now where it's going to mess you up is you got to remember there's 750 pieces before they added the 5 extra. So there's a total of 755 pieces there, which is going to give you option D. Our next one here. What fraction lies exactly halfway between 2/3 and 3/4? Well, anytime you're comparing fractions, something that's important is to have a common denominator. So for this one to get a common denominator, one of the easiest things to do is to take your bases here, 3 and 4, find our common factor. The smallest common factor of 3 and 4 is going to be 12, and make that your base. The way you convert that, and make that your denominator rather, the way you convert that, what times 3 gave me 12? Well, 3 times 4 gave me 12, so I'm going to go up top. 2 times 4 is going to give me 8. Then I have what times 4 gave me 12? That was 4 times 3, so 3 times 3 is 9. So I've got 8/12 and 9/12. The problem is, with this one, there's still only one apart. That doesn't get it for me. That's not far. We haven't gone to a small enough denominator, or in this case a large enough denominator, 24, a small enough piece, to be able to tell what's in between them. So we're actually going to go up another common denominator here. The next easiest one is going to be 24. So again, what times 12 gives me 24, and that's going to be 2. So that's going to give me 16. 12 times 2 again, so that's 9 times 2 is 18. And I can see pretty clearly there's a gap between 16 and 18 of leaving room for 17. On this one, we've got a lot of information here, and we've really got to pay attention to what's going on because there's a lot of information that we don't need as well. So Gianna's converting 12-foot by 15-foot room. We're going to have cabinets that are involved. We've got our scale of the map that's important. We've got our measurements in the picture. We know there are 4 cabinets, 3 feet tall, installed in the middle of the room here. So this is going to be 4 cabinets. And that all your cabinets are 2 feet wide and 2 feet deep. Total estimate of $2,150. That's pretty much all important information, but there's a lot in there. And the biggest challenge on this one is being able to read carefully and extract what you need. Your big clue on this one, 15-foot wall, how many inches on the scale drawing? So we've got our scale over here. 1/4 inch represents 2 feet. So if you've got 1/4 of an inch representing 2 feet, the first thing you're going to need to know is how many increments of 2 will fit into 15. So you're going to start 15 divided by 2. That's going to give you 7.5. What that does, that number right there, is how many times 2 feet fits into 15. That's important because we need to know how many 1/4 inches are going to be there. And there's going to be 7.5 1/4 inches, or 0.25 inches. So we're going to actually do 7.5 times 0.25. And that gets us 1.875. which is option B. This picture comes up for a couple of problems here. The next one, we're installing the floor. We want to know which part of the floor will not, that word not highlighted for us, be covered by cabinets. So what we have to do is figure out total area first. So our total area is going to be 12 feet by 15 feet, which gets a total of 180 feet. Now we need to start figuring out what pieces are taken up by cabinets. This one on the 12-foot wall is going to be the easiest because it gives us the increments here, 2 feet by 12 feet. So we're going to do 2 times 12, gives us 24. So this is going to be one of our pieces that we subtract in just a moment. The tricky part is this part in the center, and this is where some reading and some reading comprehension comes in to play here. It says in the center that 4 cabinets are going to be installed in the middle of the room there, and that all cabinets are going to be 2 feet wide and 2 feet deep. So we've got something roughly square here, so we know that the 4, because it says it's a scale drawing, so that we know that they're not 4 in a row, because if that's the case, it would be 2 feet wide and 8 feet long. So it would be a long, skinny rectangle. So what they've actually done is made a square here and taken your 4 cabinets and put them piece by piece here. So you've actually got 2 feet on each one of those cabinets, giving you a total of 4 feet on each side. So this small piece here is going to be 4 feet by 4 feet. Gives you 16 feet. Now we're going to take that 180 feet and subtract our 16 feet for the cabinets in the center and our 24 feet for the cabinets along the wall, and we get 140 feet squared. These are squared feet. So 140 square feet for the room. The biggest part of this one, the hardest part, is one, remembering that those cabinets are there in the center, and that being able to tell from the information it gives you down here that they're going to be 2 by 2 for the cabinets, meaning this whole thing is going to be 4 by 4. So now this one, it gives us essentially a linear equation. We've got a $650 charge for labor plus a fixed charge per cabinet. So we've got something that we get charged once that's fixed, and then something that happens over and over again. So, and it also tells us it doesn't matter what the number of cabinets, it's always going to be the same there. We go back to our original cost estimate down here in the corner, $2,150. $150. We're going to subtract our $650 to get the amount that we have total cost per cabinets without the labor. And that's going to be $1,500. So that's how much it costs to install the cabinets without our $650 charge. Now this, if we count, now here's the tricky part. We got to figure out cost per cabinet. We had 4 cabinets here in the center, because remember we figured out from the last problem that's 2 by 2 over here, so there's going to be 2 cabinets tall and 2 cabinets deep. Then you got to figure out your 12-foot wall. Again, they're 2 feet by 2 feet, so it's going to be 12 divided by 6. Sorry, that's actually going to be 12 divided by 2. Giving the answer away there just a little bit. 12 divided by 2 gives you 6. So 6 and 4 together gives you a total of 10 cabinets. So we're going to take that $1,500. We're going to divide by 10 and get that it costs us $150 per cabinet to install each cabinet. So our amount here, the $2,150, was for 10 cabinets plus our charge for labor. Now it wants us to figure out how much it would cost for twice as many cabinets to be installed. So what we're going to do is we're going to take our $650, because that charge happens no matter what. We're going to add our $10 per cabinets for twice as many cabinets. That's going to be 20 cabinets. That's $150. And that's going to give us a total of $3,650, which is option D on this one. The trickiest part on all of these is reading and taking it one piece at a time, really paying attention to what information it gives you and what information you need. So which of the following is the graph of the region 1's less than x plus y is less than 2? And one's in the standard xy coordinate plane. Now this one may seem a little funky to begin with because you got x and y in the middle. Normally when you're used to seeing these, you're either used to seeing it with an x in the middle or a y in the middle because you're on a single number line. When you're doing it together and they put them both in the middle, what you have to do is just like you would for any other linear equation, is we're trying to solve for y. We're going to get y by itself. Now, what we have here is two separate equations, and one way to think of this would be 1 less than x plus y, and another one being x plus y is less than 2. You actually have two separate equations that they've put together. Now you can do that. Now you can actually solve from right here. You can split it up and solve individually, but you can solve from right here. We're trying to get rid of x. Because it's a positive x, we're going to subtract. But just like we would here, that we would have to subtract on both sides of those inequalities, we're going to subtract x over here. We're also going to subtract x over here. Now when we do that, that's going to give us negative x plus 1 is less than y, because our x is gone, those cancel out, is less than negative x plus 2. You could write that as 2 minus x, but because we're used to that slope-intercept form, that our slope being with the x and the x being before our y-intercept, which in this case is 2, it makes it a little easier to have the x come first. Now, next thing you need to know with inequalities is that there's solid lines and dotted lines. Solid lines are going to have an equal to underneath those. There's a line underneath tells you to draw a line. There's no line underneath this one, so it's telling you that it's going to be dotted or a dash line. So all of these answer choices here have dash lines, so we don't have to worry about that. That doesn't narrow it down for us. What we're going to be doing is we're going to be looking at slope and y-intercept on both lines. So our slope on both of these are negative 1. Our y-intercept, so let's backtrack a little bit there. That negative 1, what that allows us to do is to eliminate anything with a positive slope. So we can get rid of f, we can get rid of g, and we can get rid of h, because they all have positive slopes. That narrowed it down considerably. After this, we're looking at our y-intercept. There's positive 1 and positive 2. If we look positive 1 and positive 2 on this one, and this one here we have negative 1 and positive 2. It's definitely going to be J, because it has both positive intercepts. Not as bad as it first appears.